Let's figure out where the moon came from. I'd like you guys to start by creating this table in your science journal and then using the link to the reading passage to fill it out. You are going to need to know all of these different theories as well as which ones are correct, which ones are wrong, and why. Our current understanding of how the moon formed has to do with two things. One, the Earth. Two, Theia. What is Theia? Some planet that used to exist that smashed into Earth back when the solar system was very young. The energy of that collision caused a whole bunch of material to shoot up into space. It basically obliterated Theia, an entire planet, most of planet Earth, and all of that material that was in space actually started to orbit around Earth. And Earth had a ring, very similar to what Saturn has. Only Saturn's are made mostly out of dust and ice. Ours was made out of rock. Over the next couple million years, those rocks would coalesce because of gravity, and eventually it coalesced into our moon. This is a simulation that shows kind of what happened. You can see that there is Theia, the impactor, and the trajectory that it came in on. We think that it hit not directly head on, but that it glanced off to the side, because that glancing off to the side is what allowed all of that material to stay in orbit. So let's take a look and see what happens when this planet smashes into early Earth. It obliterates itself. Most of Earth's crust is now up in space. All of this material is forming a ring that is orbiting around planet Earth. This coalesced back into Earth, and we have a whole bunch of orbiting material eventually that will form the moon. Why do we think that this is what happened? Because of what the moon is made out of. We didn't know this before the 1960s, before Neil Armstrong brought back some rocks from the moon. And we realized that the moon is made out of the same stuff that the upper layers of Earth is made out of. So the mantle of Earth is what the moon is made out of. You can see that the moon is made of mostly rock, a little bit of an iron core, which is not molten. It's actually solid now. So the moon does not have a magnetic field. The core of planet Earth, the upper layers are known as the crust and the mantle, and we have our core down in the middle. The reason that we think the impactor did not hit dead on is because what it did is it took all of this material from the top of Earth, flung that into space, and all of this mantle material is what created the moon. That was gross. Why do we think that it was created from the same mantle that our Earth was made out of? Because the chemical composition that the moon has and the chemical composition that our upper mantle have are the same. The amount of different types of rock, the amount of different types of elements match. So we know that the moon was created from the same material that the upper layers of planet Earth were created from. The only way to make that happen is if something smashed into Earth, threw all that material up into space, and the moon was created from that. Here we have a computer simulation of Theia hitting planet Earth. Each one of these particles has gravity programmed in as well as its trajectory, so it took a supercomputer a couple months in order to calculate this simulation. And you can see that once Theia hits Earth, it throws a whole bunch of material up into space, not only the obliterated Theia itself, but a bunch of material from the top of Earth's mantle. And all of this slowly, over millions of years, condensed into our moon. The moon is made out of a mix of Theia and Earth's crust, and Earth's crust is made out of a mix of Theia and Earth's crust. So our moon, as well as our upper mantle, are made out of the same mix of material, which is our biggest clue as to where the moon came from. When we went to the moon, one of the things that we found by looking at craters, we could see different layers of the moon's surface. And we found things that are very similar to what happens here on Earth when we look at volcanoes. When we have molten rock or magma or lava, and there are certain rocks that will sink in magma, there are other minerals that will float. And when you get to the moon, you find feldspar, which is a mineral that floats in liquid rock, in magma. That happened on the moon. There's a crust of anorthosite and feldspar all around the entire moon. That tells us that at one point, the entire surface of the moon was completely liquid. The entire surface of the moon at one point was a lava ocean a few hundred miles deep. A couple facts that you guys are going to need to know about the moon. The maria, or mare, are the dark spots on the moon. Mare means ocean, so they're named after oceans because before we went there, they looked to early observers as though they were oceans on the surface of the moon. What actually happened, you'll notice that all of the dark spots are roughly circular in shape. Every single one of those was a huge impact that caused the surface of the moon to become molten. And just like any liquid, it's going to level out. And so the dark areas, the mare, are very flat, level, non-mountainous, non-highland areas. Every one of them at one point was completely molten. It was a little sea of lava. And then it cooled down into what we see now today as the darker areas on the surface of the moon. Because the moon is quite big in relation to planet Earth. In fact, it's the biggest moon in our solar system. In relation to how big our planet is, it's actually protected us. It's almost been like a little shield. Not only is it big, but it has quite a bit of gravity. And so anything that's coming near Earth has to get by the moon. The moon has a whole bunch of impact craters. It's been hit billions and billions of times. And we believe that the moon has actually protected planet Earth from quite a few impacts. One of those theories that you guys read about is the sister theory. The sister theory says that the moon and the Earth formed at the same time out of the same material, but the moon has a different density. If you look at that photo I showed you, the core of the moon is very, very small. So the iron content of the moon is small, the rock content is big. Earth is different. Earth has a lot of iron in its core, which means it is very dense compared to the moon. If they both formed at the same time, then they would both have the same density, but the moon is much less dense, which means it formed after the Earth formed from some other mechanism, not the sister theory where they both formed at the same time. And even though the moon is the closest celestial object to us, it is the only other place that humans have ever been, it's still really, really far away. It's about 385,000 kilometers. It took the astronauts about 3.5 days just to travel there. It takes light about 1.5 seconds to get there. Here's the moon and the Earth and the sun all to scale. And you can see that you can barely see the moon because it's so tiny. It's about 1 pixel big. It's very small. Here is the Earth and the moon to scale. You can see that the moon is very, very tiny. When you compare it to planet Earth, it's also very, very, very far away. Most objects in space are not drawn to scale because you can't see them. You can hardly see any detail on the Earth and the moon if you draw the distances and sizes to scale. So a lot of times you're going to see images like this with the sun, the Earth, and the moon all roughly the same size. Always keep in mind though that this is never to scale. Here's a very familiar picture of our moon. This is the side that we see all the time. This is the only side of the moon that we ever see. The moon is what's known as tidally locked. Because it's been going around the Earth for so long and the Earth has so much gravity compared to the moon, this side of the moon actually has a little bit more density, which means there's more gravity. And so this side of the moon is actually locked into facing planet Earth. This is the side that nobody ever sees. There are only 24 humans in the history of our species that have seen this with their eyes. And before about 1950, not a single human had ever seen this, ever. This is the back of the moon. This is the side of the moon that faces away from Earth. Sometimes it's lit up. If the back side of the moon is lit up, the front that we see is dark, that would be a new moon. So this is our moon, even though it looks very unfamiliar to us. There are millions and millions and millions of impact craters on the surface of the moon. All different sizes, all different ages. They were formed at different times, and you can tell which ones are older. For instance, this little one here happened after this big one because it's inside of the big one. If this one happened first, this big one would have erased it. By looking at which ones are inside of other craters, you can tell which ones are older, which ones are younger. The moon has no atmosphere. Some of the rocks outgas a little bit of some elements when they are hit by UV from the sun, but the moon has no atmosphere. It may have at one point, but the gravity is so little that any sort of gas is going to escape out into space. What covers the moon is a very fine, what we call regolith. It's basically a bunch of kind of like sand or dirt that we would have here on Earth, but it's almost like baby powder. It's very, very fine. And if you zoom in, there's little tiny crabs that live on the moon. No, I'm kidding. There's not. There's no life on the moon. None.
From year to year, the moon never seems to change. Craters and other formations appear to be permanent now, but the moon didn't always look like this. Thanks to NASA's Lunar Reconnaissance Orbiter, we now have a better look at some of the moon's history. The moon likely started its life as a giant ball of magma formed from the remains of an impact on Earth about 4.5 billion years ago. After the hot material collected into a sphere, the magma began to cool, eventually forming a crust on the surface of the moon with the magma just underneath. Around 4.3 billion years ago, a giant impact battered the moon's south pole, forming the South Pole Aitken Basin and sending debris as far as the opposite side of the moon. This impact marked the beginning of a period that would cause large-scale changes to the moon's surface. One by one, more huge collisions shaped the terrain, some forming large basins that would eventually fill in to become the dark-colored patches of the moon, known as maria. They began as normal craters, but soon started to change due to the size of the impact on the relatively thin crust. Because the moon had not yet fully cooled on the inside, lava began to seep out through the cracks caused by the impacts. The resulting volcanic activity spread lava throughout the craters, gradually filling them in and cooling. Because of the high iron content of the basalt in the rock, the maria reflect less light and therefore appear darker than the surrounding highlands of the moon. Around 1 billion years ago, volcanic activity ended on the near side of the moon as the last of the large impacts made their mark on the surface. The moon continued to be battered by other impactors, although they were much smaller than the objects that formed the largest basins. Some of the largest, most recent, and best-known impacts from this period include the Tycho, Copernicus, and Aristarchus craters, which are unique due to the complex system of rays that stretch out from the impact site. Finally, we arrive at the moon that we see today. Though the surface continues to be affected by impacts, the rate has slowed down drastically to the point where the moon appears unchanging to the human eye, as a permanent record of its own history, and a glimpse of how craters may have formed here on Earth. As we continue to study the moon, our understanding of it improves, giving us new insights not only into how it has evolved over time, but also how other rocky planets in our solar system have come to look the way they do. With new missions, new instruments, and new technologies, we will continue to improve our knowledge of the moon and better understand the history of our solar system.
Tomorrow we're going to go a little bit more into how we have explored the moon, a little bit more into Apollo and going to the moon and the different things that they found once they got there.